Okay, now what we're going to do now is write some numbers on the board. We're going to write them over here, and then we're going to go ahead and look and try to identify what type of numbers that they are, and put a little check mark in the different, in the different columns. And you'll find out that most numbers have check marks in different columns, more than one column, because you can see from our little hierarchy tree that we had over there, a number can be, can have different labels associated with it. So let's go ahead and do that. Let's start with the first number. The first number was, let's say, the number 30. And let's just go right across the top and see if that is there. So it's a real number because, as we said before, pretty much any number that we have that doesn't have an I in there for imaginary is always going to be real. Rational. Is it rational? Can it be written as a fraction? Well, of course it can, because 30 divided by 1, 30 over 1, is possible. Is it irrational? No, it's not irrational because it's not an infinite decimal that goes on and on forever. Is it a whole number? Yes, it is, because a whole number, remember, are the numbers that are 0, 1, 2, 3, 4, 5, 6, and they go on like that, including 0. Okay, is it an integer? Well, yes, it is an integer, because remember, integers are all the negative numbers, all the positive numbers without any decimal, and including 0. So that is an integer. Is it a prime number? Well, it is not a prime number because I can divide 30 by the number 10, I can divide it by the number 15, I can divide it by lots of different numbers and still have an even division. So this number is real, rational, whole, integer. And we could even have more columns with natural number and all this other stuff. They're just labels. I'm just trying to give you a little bit of practice here. All right, what about the number 0? Well, 0 is a real number. Just like we said, pretty much any number is real unless it has an imaginary thing attached to it. It's rational because you can write it as a fraction. The number 0 divided by 5, 0 over 5 is going to be equal to 0. 0 over 10 is going to be equal to 0. So you can write it as a fraction, so it's rational. It's not irrational. Basically, a number cannot be rational and irrational at the same time. Either you can write it as a fraction or you can't. That's what that boils down to. It is a whole number because whole numbers are the numbers 0, 1, 2, 3, 4, 5, and on up. It is an integer because integers include 0. And prime number is excluded from being 0 or 1. And we talked about that when we talked about prime numbers. All the prime numbers, they don't count 0 and 1. They go up from there. The next one I want to talk about, 0.50. Is it real? Of course it's real. Pretty much all these are going to be real. Is it rational? Can it be written as a fraction? Well, yes, because we can write it as 1/2. It's not irrational because it's going to be one or the other. You can't, you can write it as a fraction, so that's not going to be there. Is it a whole number? Well, no, it's not a whole number because whole numbers are 0, 1, 2, 3, 4, 5, etc. Integers are all the positive and negative guys, but they have to have no decimals, so it's not an integer. Is it a prime number? Well, it's not a prime number either because those are whole numbers as well that are divisible by itself and the number 1. So the number 0.5 is only real and rational. Okay, the next, let's talk about something a little different, -3/8. So we have a fraction here, -3/8. It's a real number. Is it rational? Well, yes it is because it can be written as a fraction. It already is a fraction. It's not irrational for the same reason. It's not a whole number because those are, 0, 1, 2, 3, 4, 5, whatever. It's not an integer. It's not prime because all of these are basically numbers like 0, 1, 2, 3, 4, 5. They can't have fractionals or decimals involved. So this is just real and rational. Okay, let's look at the number 1. It's real. It's not imaginary, so it has to be real. It's rational because you can write the number 1 as 1 over 1. It's not irrational for the same reason. It is a whole number because whole numbers are 0, 1, 2, 3, 4, 5, 6, 7 on up. It is an integer because those are the positive and the negative numbers with no decimals. So that fits into that category. It is not prime though because prime numbers from our definition we just had on the other board cannot include 0 and 1. So it's not prime. All right, now let's look at the number pi. Is it a real number? Yes, it is real because there's nothing imaginary about the number pi. There's no I there. Is it rational? No, it's not because you cannot write the number pi as a fraction. Is it irrational? Yes, it is, our first irrational number. Is it a whole number? Well, no, it's not because it's got a decimal involved. Is it an integer? No, because it's got a decimal involved. Is it a prime number? No, because it's got a decimal involved. Those last 3 columns are only going to apply to numbers that don't have any decimal. So that's basically it. Pi is real and irrational. Let's look at the number 2.12, just the decimal, 2.12. Is it real? Well, yeah, it's real. It doesn't have any imaginary parts to it. Is it rational? And I'm going to tell you, yes, it is rational. You can write it as a fraction. And you may not know right away if these decimals are written as fractions, but the way that you really look at it is, if you have a number that has a decimal that just stops eventually, like after 2 or 3 decimal places or whatever, you can always write it as a fraction. I mean, in this case, for instance, this guy, 2.12, you can write it as 212 divided by 100, or 212 over 100. Because if you put this in your calculator, it's going to move the decimal point 2 points back, and it's going to give you what you're looking for. If you dump this in your calculator, you'll find that it equals this. So you can write it as a fraction, but you're not always going to be able to think of the fraction that you can write it as, but you know that if it stops, or if it has a repeating pattern of any kind, like 2.105, 105, 105, 105, any kind of repeating pattern, you will be able to write it as a fraction. All right, so it's real and it's rational. It's not irrational because we can write it as a fraction, and none of these apply because we don't have any kind of we have a decimal point involved. What about the number 1.11, and we'll put a bar over the 1, so what this means is it's 1.111111111 on out to infinity. It's real because there's no imaginary number involved, and I'm telling you based on our definition that it is rational because there's a pattern here. It does go on forever, but the pattern is that it's all ones. So there is a fraction that would equal that. Now, I don't know what it is, but it's just sort of a mathematical truth that it's going to be that way. It's not irrational because you can write it as a fraction. It's not any of these whole number, integer, or anything else because there's a decimal involved. What about negative 2.5? Well, yeah, it's real. It doesn't matter if it's negative or not. It's a real number. It doesn't have any I or imaginary part to it. It is rational. Just like I said, the decimal point stops. Now, in this particular case, I know how to write that as a fraction. You can write that as negative 5/2. If you put 5 and divide it by 2 in your calculator, negative sign out front, you'll get negative 2.5. Okay? But as I said, you don't need to know the fraction that's equal to. You just need to know sort of the rule. And none of these other things apply because there's a decimal involved. Now what about negative square root of 2? If you get the square root button on your calculator and put 2 in there and hit the square root, stick a negative out front, it's real. I mean, it doesn't have any imaginary parts to it. It is not rational though, because if you look at it, the numbers that you'll see in your calculator, even if you get a computer, you'll find that there's never any pattern. So there's no way to write that as a fraction, and so it's irrational. And it's definitely not a whole number or an integer or a prime number because there's decimals involved there. And what about the number 5? Well, it's real. It is rational because we can write it as 5 over 1. It's not irrational for the same reason. It is a whole number because we can, whole numbers are 0, 1, 2, 3, 4, 5, and on and on. It is an integer for the same reason because those are positive and negative numbers with no decimals. It is a prime number also because the number 5 can only be divided by the number 1 and the number 5 itself. It can't be divided by anything else, and if you try to divide it by anything else, you're going to get a decimal. So that's basically it. You see, these numbers can have multiple labels. They can have multiple labels. And that's because there's overlap. The integers have overlap with the whole numbers. I mean, the integer is more broad there. And of course, every prime number is also going to be an integer, and et cetera. You'll just sort of see that. The only thing that is sort of going to be one or the other is going to be rational versus irrational. Either you can write it as a fraction or you can't. So that concludes this section. I know it probably wasn't the most thrilling section just to learn about numbers and how to classify them, but every book starts with this material just because everyone has to know the definitions. Math is just like a foreign language. You have to know the definitions. If you do, then when someone says irrational number, you won't worry about it. You'll understand what they're talking about, and so you'll do well. If you don't know what an irrational number is or a prime number, then when you see that on your test, you're going to get stressed out, upset, worried, and then you're not going to do well because you're worried about it. So Make sure you understand this material. It's important for the sections that follow. We're going to take you baby steps, one step at a time through this class, so that by the end of it, coming in here, you have no idea what algebra is about. Coming out the other end, you're going to have a fair amount of really good pre-algebra skills under your belt, ready to tackle Algebra 1 and do really well in those courses. I'm Jason. I hope you've enjoyed the lesson. Let's go on into the next one and continue on through the course.